Our first speaker this morning is Bob Bregant. He is a senior IT security engineer at the University of Illinois at Urbana-Champaign. He's currently working from downtown Chicago. He was formerly responsible for the Bro development at the U of I. Welcome, Bob.
Thank you. Good morning, everybody. Not quite sure how I got this wonderful 9 a.m. time slot. My only guess is that maybe somebody took notice when I forgot the article at the beginning of The Ohio State University, and that's why I got stuck up here. This was the title that I submitted to Seth when he did the initial call for projects, for talks here. And while it is sort of cute and funny, I didn't really put a lot of thought into it, and it really doesn't convey what we're going to be talking about during this presentation today. So I came up with one that I thought was a little more appropriate, which is more Bro-Arista integration, because we're talking more about how things fit together. We are talking about how it fits it all together with Bro, but of course this sounds a little bit more like the kind of thing that Justin was talking about, where Bro is really interacting with the Arista. So that's not a great title either. And finally, I settled on this one. This is really more what we're talking about. We're really talking about the generic properties of how you get all of the data from your X taps and spans and whatever all across your network to your Y number of Bro machines that you've got somewhere, and for whatever values of X and Y you may choose. And I am including some very Arista-specific examples. I'm including, in fact, actual config lines, because I feel like talking about it in the generic sense is good, and we'll do some of that. But if you actually see how it works and see how you would actually do some of this stuff, even if you're not using the Arista hardware, if you're using some other vendor's products, I'm certain that you can get some useful bits out of it. As I was introduced, I'm Bob Bregant from the University of Illinois. I was a senior IT security engineer. I am still technically. And I performed the production Bro deployment at Illinois, and I designed and deployed the TAP network, so how we're getting our data from the TAPs back to the Bro cluster. Although right now I'm technically starting off as an IT security analyst, trying to use some of that data that Bro's generating for us to actually get things done on the IR side. Before I really get into the meat of it, though, I do want to do a little bit of a disclaimer about what this isn't. This is not going to be a vendor or sales pitch. I don't work for Arista. I'm not getting compensated for Arista. I know that I'm a state of Illinois employee, and people might expect like some kickbacks or something going on here, but I haven't figured out how to make that work yet. I really should get on that. But I really take more the Justin school of thought, where these boxes just show up in my office, and that's great. That's all that I really want involvement in that. This is also not a talk about something new that I've come up with. There's nothing novel here. There's nothing that I'm going to be releasing on GitHub. This is all stuff that you guys could be doing today. You could have been doing it last week. But this is how we've been doing it. And this is also not, the final thing that I want to say is this is not a presentation by a product engineer. I don't know the internals of the Arista hardware. We've got a guy in the back who works for Arista, who's our sales engineer. He knows everything you want to know about the Arista hardware. I'm not that guy. So if you want to come up to the mic and ask questions about buffers and all sorts of, it's not going to get a good answer from me. So let's do some brief background, since we're going to be talking about how we're moving the TAP traffic around on this network. I figure I should probably tell you a little bit about the network so you have some idea where we're coming from. We've got a 10 gig core network. They just upgraded to 40 gig, but we're not really utilizing the 40 gig, so it's effectively still a 10 gig core network, servicing about 320 buildings spread over about 3 square miles, and that network services about 55,000 people. That's a lot. It's kind of big. And it's got, of course, there's not just one way in, because that would be too convenient. There are actually several 10 gig connections out to the rest of the world, and one big fancy 100 gig connection out to Internet 2. As Nick was talking about yesterday, what that means for the security people in the room is, yes, dragons. There are dragons everywhere. Everything, the bad stuff is everywhere. And so we can't just select one point and put Bro there. Bro has to be in lots and lots of places. So let's talk about the Bro deployment here. Like I said, you've spread out over that kind of area. You've got that much stuff all dispersed. You can't monitor everything. Actually, if we're interested in monitoring everything, Seth's going to pass around a hat at the end of the talk. If everyone could chip in $50,000 or $60,000, I will work on that, but that's right now on the current budget, that's not going to happen. So what we're doing is we're selecting the points that are actually the most interesting. Things, points where, the VPN, the unencrypted side of the VPN comes in, points where wireless meets the rest of the campus network, the exits to the network. Of course, those points are not nicely consolidated either, so we've still got a little bit of dispersal, but that makes it at least a little more manageable. And then that data is then fed back, it's backhauled to the central Bro cluster, because we still don't have any way to do nice dispersed Bro yet. So that data is all sent back to a central data center where it's analyzed. Of course, like I said, that means that those taps and spans are spread out over a good bit of the 3 miles. We've got to have some way of getting them back to our central cluster, and we can't just take the fiber that's coming out of that tap and just run it across campus. There's all sorts of reasons we can't do it. Primarily, we don't have enough fiber to do it. We have a lot of fiber, not that much fiber. So we've built a tap network. And the tap network, we've built it sort of like a shadow campus network. It is in the form of our network. Our network relies on several nodes, networking nodes that are spread throughout the campus, where all of the buildings connect up into, and we've got machines out in those nodes that then talk to each other and talk back to the central Bro cluster. They're connected to each other with dedicated cross-campus fiber, so we're not touching any of the real networking hardware here. We don't have to worry about messing up networking's nice switches. So we've got the switches out at the tap locations in the nodes. Nice thing about having switches out there, it minimizes the light issues. I know in previous configurations on this campus, there had been some situations where taps were installed 90-10 the other way, so that 90% of the light was going off to Bro and 10% of the light was going where it was supposed to go, because that 90% of the light needed to go halfway across campus. And so the nice thing about having these switches there is all of our taps need to go about 10 feet. And then they get to a switch which regenerates the light, does the fancy optical, electrical, optical thing, regenerates the light and shoots out brand new powerful light across campus. Also, those switches allow us to minimize the traffic because we can do fancy things like filtering and all that out there so that we're not sending a whole bunch of traffic that we're then just going to drop on the floor all the way across campus. And then finally, there's a switch at the Bro cluster which splits stuff out and does all the fancy stuff to get it out into our mini Bro boxes that are actually analyzing the traffic. So that's a really, really, really high-level overview. Now let's talk about some of the sort of more nitty-gritty things, how we actually do some of this stuff. We do the aggregation at the nodes, at those node switches, because like I said, fiber isn't free. We have a decent amount of dark campus fiber, and that's what we've been using to connect these switches back and forth, but we don't have enough of it to just run every tap on its own couple of strands back to the Bro cluster. So we aggregate these things into bigger pipes. So you've got 4 10-gig connections coming in off those taps, and you can aggregate that onto one nice big 40-gig piece of fiber that then you shoot across campus. It really is, if anybody's sitting out there thinking, wow, that sounds really simple, that sounds like it's just a lag, yeah, it is. It really does just lump stuff together into one big LACP lag. We just tell it, do passive LACP, so just assume that you're in a lag group. Don't try to actually send the LACP packets, and just regenerates the light, shoots it across campus. Works great. It does have a couple of caveats though when you're setting this sort of thing up. The first caveat is when you're planning it, don't forget that you got to double things. So if you've got a 10 gig tap and you're thinking, okay, so I've got one 10 gig tap, that's going to be 10 gigs of my backhaul that I'm going to be aggregating. I've got another 10 gig tap, that means that my backhaul is 20 gigs. Don't forget, those taps are full duplex, so you've got 2 10 gigs for each 10 gig that you're doing, so that's 20 gigs across the backhaul for the first tap, and up to 40 then for the second one, and when you start dealing with 40 gig taps or 100 gig taps, it really gets ridiculous very quickly. Of course, if you're tapping both ends of something, no problem. Then you only really need, if you're only concerned with the outbound traffic out of the router, and you've tapped both ends of the thing, then you only need 10 gigs in each location. It still adds up to 20, but it's conceptually a little different. And the other thing that I want to mention is that you really do want to label everything when you're doing this, because We've got these things that are out in these nodes. We don't actually see the boxes. It is really, really helpful to, as you're going, label things, because you're going to come back 2 years later and one of those interfaces is going to be down, and you're going to go, wonder what that's doing. So it's always a good idea to go ahead and label everything. So now we're going to move on and do a little bit of, here's a very simple example of this is exactly how you would set up TAPAG mode onto an Arista 7150, really, because that's where you're going to get this TAPAG functionality that we're going to be using. And this is literally how your command shell would look. You could do this through the API. You could do this through some of their other methods. I think they've even got a way where you can configure the switch over XMPP, but I just go into the command line. It's SSH, it works. So you enable, you go into config mode, you go into tap aggregation config mode, and you set it to mode exclusive. And that's a really neat thing, because what we're basically telling it is, yeah, all that stuff that you know about being a switch, forget it all. Don't worry about that. You MAC tables, can't it? No, none of that. You're going to do exactly what I tell you to do, and you're going to allocate all of your stuff to being tap aggregation. You're going to allocate all of your memory, all of your power to just doing what I told you to do. Then we're going back into config mode. We're turning off spanning tree, turning off a couple other things just to get rid of them. And then now this is how you quickly just set up some of the groups here. If you had some ResNet taps coming in on your interfaces 33 through 36, let's just pick some 4 random interfaces. You tell it that those are taps. That tells it that it's just going to take traffic in on that interface. You don't have to worry about a lot of, what if you misconfigure it. Just tell it it's a tap. It knows what to do with it. And you tell it it's in the group ResNet taps. The groups become important in just the next slide here. And then that's just basically giving you a logical way of referring to those things, so that when you're doing the traffic flow within the switch, it's easy, it's logical, it makes sense. Pick another couple, say those are your VPN taps, do the same thing to it and put it in a different group. Okay, the other side of the switch, though, is saying, okay, now I've got all this data coming in, where do I want it to go? I want it to go out a nice big group of interfaces, so I'm going to put 4 things together. We had 6 on the other side. We're just going to go to 4 here, and we're going to say those are the production cluster. Those are going to the production cluster. We'll make it a nice port channel. It's, again, setting the mode on so that it's just doing it, and it doesn't have to worry about doing LACP. Then we go in to configure that port channel. We tell it this is a tool, which is the opposite of a tap. It's just their terminology, whatever. And we tell it take all the traffic from both of those groups and save that. And now that's literally those, 15, 20 lines? That's how you do it. And that actually has all of that traffic going out, going in those interfaces, going out the other interfaces. It's a couple lines of config to do it. If you want to add another couple interfaces, it's really pretty trivial, and I assume that's pretty close to how you do it on other stuff. I just don't know, because this is the stuff we've got. One of the other things that you get to do, which is kind of fun, is traffic duplication. Because, of course, this is the theme here, is that fiber isn't cheap. So anytime you can minimize the traffic going between 2 points on that big, long piece of fiber that you're doing, connecting your tap nodes to your actual cluster, go for it. So what we're doing with the duplication is you try to make sure that you're doing any duplication, you try to make sure that you're doing at the very last possible second. So we do all of this at the cluster side. And there are some cases where you might want duplication. I know normally we talk about deduplication. You want to minimize the amount of stuff, but sometimes you do want more than one copy of something. The first case, which is the case that we're using, of course, is when you've got a test bro cluster. And of course, in that case, you probably don't want all of your traffic going to that test bro cluster. If you've got 10 nodes, if you've got 10 bro boxes doing the production side, you've only got 4 on the other side. You don't want to overload them with all your traffic, but you can select just a little bit of it and say, hey, send this off to the bro cluster, to the test cluster, so it's getting real traffic in real time. You can do real testing on it. You can play with that. It's great. Also, if you want to send stuff to other security tools, if you've got a FireEye, if you've got something else, who knows, you could pick off traffic that you wanted to send there. You could also just do regular, normal splitting of traffic. If you've got traffic that you want to go to a special bro cluster, like let's say you've got a special PCI bro cluster because PCI is weird, then you could send all your PCI traffic over there. And it doesn't have to touch your real bro cluster. It doesn't have to do it. Your real bro cluster doesn't have to be in scope or whatever. None of those problems. And so there's a couple of ways you can do it on an Arista if you want to do it this way. The simple way is just to use the tap aggregation functionality using those groups that we were talking about. They do have more complex, they do have some weird deep packet inspection stuff where you can match like bitwise into the packet by like 200 bytes or something. It's really complex, but I mean, if you needed something really fancy, maybe great for you. I'm just going to show you real quick how to do it if you wanted to do it this way. Let's say that we've got a test cluster now on that's also coming off of that switch. This is every one of the commands that you'd have to run to say, now I've got a test cluster, I want the VPN stuff to go to the test cluster. You just have to set up the test cluster port channel and tell it that you want the VPN stuff going there. That's it, now the VPN stuff's going to your port channel. The second to last thing that we're going to sort of discuss here, the filtering. Because like we said, sometimes you want to do duplication, sometimes you want to do deduplication though. Now, as again I always have said here, fiber isn't free, but neither is the CPU time. In addition to the fiber not being free, when you've got traffic that's going through your switches, you've got traffic making it to your bro nodes, it's eating up CPU time, it's eating up space on your buses. It's not, if you're just going to drop it on the floor, you might as well get it as soon as you can. So go ahead and drop it as fast as possible. Oh no, spinning beach ball of death. 1 second. Okay, I'll just keep talking and we'll assume that the Mac will catch up at some point. So you should be trying to drop your traffic as early as you can if you're not going to analyze it, which in this sort of a situation, in the situation that I've described to you, how we've got our tap network set up, that means dropping it way out at those nodes, and you can do that either on the ingress or the egress. With the Aristas, there's some limitations on how you can do egress filtering, but ingress filtering works great for most things. And so, 1 second, give me a second. Now I'm on to 2 slides ahead, and so I'm just trying to work real quick and figure out what I'm, no, now I'm lost. Let me see if I can get the Mac back. This is annoying. Nope. Okay, that looks frozen. Fun. So now we'll do it a little off the cuff. So there are the normal reasons that you might be filtering. You might be doing something like Justin's Domino presentation that he showed off 2 days ago, where you'd be taking these gigantic flows that you can't normally deal with, and you'd be saying, I'm going to, on the fly, bro is going to set up filters, ACLs, to block those Domino flows. But there's also other things that you might be interested in filtering. You might be interested in doing more systematic filtering that's less on the fly and more, well, this is just how the network is set up. For example, if you've got traffic like Netflix that is just high volume that you're not interested in, you could probably write an ACL, especially if you've got a local Netflix mirror that just says, any of the traffic from that box I'm not interested in. An example that we're using on our network is if you happen to have an exit firewall that's syslogging, let's say 80 gigs of syslog a day to your central syslog host. You're already getting the logs anyway, but that syslog traffic going from the exit firewall has to pass past your bro tap in order to get back to that syslog host. That means that not only is your syslog host logging that 80 gigs a day, bro is also, through the fancy syslog protocol parser, logging that 80 gigs a day. I don't need it in 2 places. So the nice, simple solution for that is, of course, you tell the switch that you're doing the tap from, hey, any traffic going from the exit firewall on the syslog port, drop it. Just drop it on the floor, and that then allows you to turn back on the syslog protocol parser and see all the other syslog stuff without having that 80 gigs of whatever stuck in the way. A couple other things that you might be interested in doing. You can, if you've got encrypted traffic, once you can do something similar to what Justin's Dumno is doing. Once you've got all the fancy encrypted metadata out of there, all the certs and everything, you should be able to tell it, the rest of this encrypted session, I've got all the data I'm going to get. I don't really care about the rest. You could use something like Justin's tool to drop that. And finally, if you've got any internal VLANs that you really don't want to monitor, for example, let's say you've got a tap somewhere where you're also picking up a storage VLAN and you're just, I don't want to see that on my bro. I don't want my bro boxes trying to parse that. It's just the volume's it's not worth the trouble. You could easily filter on the VLAN and say, I don't want this VLAN, drop it on the floor, and that would save you processing time not only on your bro boxes, but also on the switches, getting your data to your bro boxes, and it would save you volume on that fiber link between your taps and your central cluster, which of course means you need to use less fiber potentially, which is always good. Now we would be, of course, at the point where we would be showing off a wonderful config that would be just showing you how to do. There we go. We'll just restart it. We'll be showing you how to do the filtering if you wanted to. Oh, I can answer a question while I restart this system.
Wait for the system to catch up. So given the traffic that you're seeing, how many gigs worth of logs are you getting a day, and how are you retaining it?
Okay, so that's, I can talk about that. So we've actually, our Bro system is generating something like 275 gigs of logs a day. Those are actually being rotated every 20 minutes because we've only got a very small amount of disk on our Bro systems. And actually then those are being syslogged with a wonderful little program called rsyslog, which adds reliable delivery on top of syslog through the RELP protocol. And those are being syslogged back to our central syslog host, which has a nice 8 terabyte storage array on it. And then that central syslog host does parallel bzip compression on them every day, so that then we can store, I think we're storing 90 days of Bro logs on there, because it compresses about a 10-to-1 ratio, so you're looking at only about, if we started with 275, it's only 20 gigs a day or something after you compress it. That's not bad. Ideally, once we get, we're sort of in the process of purchasing a product to do some analytics on top of that would then take that data in through the indexing. That process is still ongoing with the state's procurement office, though, so who knows when that'll happen. Now we're back. That's real quickly how you would do the filtering. If you wanted to set up, these are literally the rules that I'm using to block that syslog traffic, with the exception that I've anonymized the host that I'm using to store my syslog data, because I don't trust anyone in this room. And so this is really, it's just very quickly, you set up an access control list and you tell it you want to deny any UDP traffic from any host to your syslog host on 514. And then I'm also running syslog on a bunch of ports higher than 1500, so I just blocked any of those, exited to save it, and wrote it out. That works really nicely, really quickly. These ACLs are not difficult to write, and I'm sure they're just as easy on any other vendor's software, so it's really, this is something that's a very low cost to you when you're configuring it, and it's got a pretty decent rate of return. Oh, hey, we've got another question.
I was just going to ask, have you run into frustration with the lack of IPv6 filtering yet?
No. I have not. I've seen in the manual that they have IPv6 filtering. The IPv6 deployment on our campus is very limited, so I haven't had to deal with it on this campus, so I haven't actually tested it. I'm not going to say it works, because I don't know if it does.
I don't think it does work now. So that's...
Don't know if it does. I've seen the manual lines that claim it does, but I don't know if it does. So, yeah. But we just haven't had to deal with that area yet. So. Okay, the last sort of function that we're sort of performing with these tap aggregation networks is the symmetric hashing. This is the stuff that goes on the cluster side. This is how you get the data split out of those, those big pipes that you're shooting across campus with and into the boxes that you're actually doing the Bro analysis on. You're doing a very similar thing once you get the data into your host to split it across your 10 Bro processes and your 3 snort workers or whatever. But this actually, it also needs to happen, of course, at the network layer too, because everything from ABCD to EFGH, it actually does need to go to the same system as the stuff from EFGH to ABCD. If it doesn't go to the same system, it doesn't matter how well configured your host-based hashing is working, you're still, if the traffic's not going to the same machine, it's not going to get handled by the same bro worker. You're going to wind up with those nice con.log lines that have the state that's all lowercase, and then the next one that's the state that's all uppercase. Yeah. And so now if you're thinking about, well, how would I go about doing this? You might be thinking, well, I could maybe do this even simpler just with a quick ACL, but I'll just split up the internet into however many groups I need. It doesn't really work that way though. You've got to do something a little more complex because the internet's not a nice even distribution. And even if it were a nice even distribution, the bits that you're going to see aren't, because your traffic, the traffic that involves your IPs, is going to be much more prominent on your network than the traffic going everywhere else. So we really do need to do something fancy like the hashing here, so that you're making a nice hash out of the two IPs, and you make the hash in such a way so that if you switch the order of the IPs, it still hashes the same thing. And then that's how you wind up splitting it out. There are a couple of caveats to keep in mind when you're doing something like this, though, which is things like it can't split a single flow. If you wind up, if you've got 7 bro machines and you've got one guy who's doing nice big 10 gig flows between one single source and one single destination, you can add all the bro machines that you want to that situation. You can split it, 50 different ways, and that 10 gig flow is still, because of the nature of how you've got to do the load balancing in Bro, still going to go to that same one machine and going to overload that same one machine. So this is not going to help you in that case. That's a situation where Justin's domino thing might help, but this is not going to be helpful there. And this kind of a situation, no matter how smart your hashing algorithm is, it doesn't know anything about the load on those boxes. It's going to try to distribute things evenly, but if the network traffic just happens to be weird, it could very well wind up overloading a box. It could wind up sending, several really gigantic flows to one machine, and that's something that you do have to sort of keep an eye out for when you're setting these networks up. You do have to keep an eye out on how the distribution is actually working out in the real world. There are some configuration parameters you can generally play with on these boxes to try to tweak that. You can play with them, and again, that's not something that's specific to Arista. You can play with them on pretty much any vendor's box, but you're never going to be able to get it so that it knows that this bro box is overloaded and it's going to send more traffic to this other one. It just doesn't work that way. Real quickly, how you'd set this up if you wanted to. You just define a load balance policy, pick the chip that's actually doing the load balancing, set up a load balance policy. The port channel hash seed there, that's the Arista way of setting that function that I was talking about, the parameter that allows you to sort of tweak how the distribution's working. I just pick a random hash seed. You can pick anything you want from 1 to 39, I think, on the Aristas. And that's just changing slightly the way the distribution works. It doesn't work in any logical way that I can articulate, but if your flows are working out so that you've got a bunch of stuff going to one box and not very much going to the others, you can play with that and see. And trying different values will probably get you a better distribution. And then we want to do symmetric distributions. Some people might be able to do a distribution based on the IPs that they're seeing, but if they're doing any of their distribution based on, well, this source IP is going to go to this box, this dest IP is going to, then it needs to be done symmetrically, like I was saying. And then we're only selecting, when we're setting this up, the recommendation based on how we've sort of seen it, and this is actually a recommendation that we stole from NCSA, is really to only use the IP fields when you're doing it, because you wind up with protocols and flows that are using multiple ports. If you try to do the hashing based on IP and port, you can theoretically get a little better distribution, but anything that's jumping between ports is going to wind up going to different machines. It's going to be analyzed by different workers. In this situation, if you just do it with the IPs, you can get it all to the same box, and so you've got better odds of it actually getting hit by the same worker in the event that Bro can actually, when Bro does something with that, it'll all be done by the same processor. And then we just pick some ingress interfaces on the Aristas. That's just how you apply the load balancing, is to the ingress interfaces, and we apply it, and we're done. Sort of a final wrap-up thing is we've got some fun facts that we've, just sort of general things about this topic. The first thing is, of course, that even though this is an option on just about every one of these switches, the Arista stuff, the Gigamon stuff, everybody's stuff can do this, the packet truncation, and it looks like a great way to save your bandwidth. We've been talking about fiber's not free. We've been talking about, you try to make your CPU do the least amount of work possible, so, try to cut down on that traffic early, cut down on it. If you try to do it by truncating the packets, that's going to break things. It's going to break things very badly. Try to cut out, if you're going to be cutting things out, cut out packets, cut out flows. Don't just truncate things, though. It doesn't work that way. A note about the symmetric hashing. Interestingly, so if you think about the way the symmetric hashing works, realistically, it's going to create a hash of those values, and then it's going to try to split things based on that hash. And it works a lot like a binary tree. And so it's going to say, was the first bit 0 or 1? If so, split it. And now I've got 2 nodes worth of stuff. If I need to get to 5 nodes, it's going to split those 2 again based on the second bit. And I'm grossly oversimplifying how it actually works, but this is conceptually, it gets the point across. And so now I've got 4. But now if I need a 5th one, I can't, then redistribute the traffic that I've already split out into those 4 groups so that everybody gets 20%. I've got 4 groups of 25%. And so realistically, I need to then split one of those to get a 5th node, but that means that I've got 3 groups now of 25% and 2 groups of 12.5%. So when you're doing this symmetric hashing, you really need to be, if you want to get the full value out of it, you want to be incrementing it in powers of 2. So if you've got 2, you're going to get the best improvement when you go to 4. If you've got 4, you're going to get the best improvement when you go to 8. And that's just how it works. It does seem like this is cross-vendor. I know we chatted with NCSA about their former Gigamon deployment, and that was an issue that they were running into. One other thing, the Arista hardware is running Fedora underneath it. You can get access to that bash shell. You can have root access to that bash shell. And I know some of you are going, oh God, Fedora. But it is kind of nice to have access to that bash shell because you can do things like install software. I've seen the Arista hardware running Splunk on the actual hardware, just the Splunk agent, of course. It'd be ridiculous to actually run Splunk on it, but and pulling all sorts of neat stats because it can actually run a local agent. If you've got some sort of shell script that you want to run on your switch, it's a neat trick to be able to just drop down into the shell and do it. And finally, there is a web UI for most of this stuff. Arista's got one that I hear is a work in progress. Other vendors have their own fancy UIs for this. And so if when I was standing up here putting those config lines up and you were thinking, wow, that is about 20 config lines too many, and you'd really just prefer to point and click and do all that, there are lots of vendors that can accommodate that for you. It's just not the way that I like to do things, and so that's not how the slides are set up. So now we're pretty much done. If anybody's got any questions, feel free to ask at this point. If you have questions later, or if you have questions not related at all, we've got the Bro channel on Freenode. We've got the Bro mailing lists. I can answer things. And somebody I'm sure will answer, and it will probably be Seth, actually. But if he's in the room. Yeah. Yes, sir.
Yeah, I'm going to be trouble again. Have you modified any of the MTUs at layer 2 to simplify the flows?
We have not.
Okay. Let's see. What accelerated cards do you use on your Bro clusters?
So we've actually got Miracom cards on there. We started with Intel cards doing the PF ring stuff, and for just management simplicity, we found that the Miracoms were much easier to handle for our purposes.
Have you integrated Bro into address planning system?
No, I'm not sure I'm not sure I follow, but I'm certain the answer is no. But if you want to explain, I'd be interested in knowing what do you mean by address planning system?
People don't always use spreadsheets. They use systems that integrate into DHCP and DNS.
Oh, yeah,
like
the
context.
IP address management type systems.
Yeah.
Yeah, so the campus does have one of those, and we have not done any Bro work into that, but there is one on campus.
Thank you.
How much traffic's on your 100 gig link?
Not a lot. And so the fun thing about the 100 gig link is, of course, it's a 100 gig wave. It is. It absolutely is. But of course, we're not offering like 100 gig to any one researcher's desktop. And so the great thing about the 100 gig wave is, since it just got spun up and we've already got Bro set up, as we're setting up Bro, we're sort of saying, okay, you're all getting 10 gig out of this router that then does 100 gig. We're going to tap all your 10 gig links because we know how to tap 10 gig, and tapping 100 gig is ridiculous. Mostly just expensive. And so we're just tapping these 10 gig links as they come on. We charge the users for their, it's just part of the charge for setting up that 10 gig connection. But we've only got a few that are going out there right now. I don't even think we have enough technically connected to fill the 100 gig link if they try. Do we? I don't know. Anybody else? Anything else?
And I know that Arista makes sort of a smaller switch based on the Intel Fulcrum chip, and then they have a bigger chassis model. Do you want to try and flesh out those actual details? I know it's not a vendor talk, but it might be helpful to understand that architecture.
It's not a vendor talk. I do happen to have a couple of the little ones and one of the big ones. So I can tell you a little bit about them. The big one right now doesn't do the symmetric hashing. So right now you can't use that to do the final sort of step in front of your Bro cluster. I've been told that they're going to do that at some point in the near future. But right now, realistically, most of this stuff, we're just running it on the little ones, the 1U 7150 stuff. We're using the 64 port because then it's got the 440 gig connections, which is nice for taking in a bunch of 10 gig and then shooting it back out over 40 gig when you're shooting it across campus. And they're much cheaper and much easier to fit into our networking nodes than those big chassis. So that tends to be our preference right now. If nobody else has anything, I think I can hand it back over to our wonderful planners.